So what is the question beta here beta? Open organ pipe of length 1.5 meter is dipped vertically into the water. What do you mean by that one? When an open organ pipe of length 1.5 meter is dipped vertically into the water and it is slowly raised, and a tuning fork of your frequency 600 hertz is been set into vibration and placed above the open end of the raised tube. Then find the maximum possible resonances which have been heard. And you know that whenever an open organ pipe, like say for example, this is your open organ pipe, it is open at both the ends and it is dipped into what? Water. Right now, say for example, this is your cylinder in which water is being filled. Say for example, this is your cylinder in which certain amount of water is being filled right now here. Okay, so this is the amount of your water which is being filled. What you're doing, you're taking this tuning, this open organ pipe and immersing into the water like this. So when you immerse in the water like this, so this part will act as of what beta? Closed organ pipe only, no? So whenever the vibration is coming from this one, it touches the water, reflects back, again it will go right. That means it will be acting as a what? Closed organ pipe. So when an open organ pipe is immersed in the water, that will be acting as what beta? Closed organ pipe. So length of this one will be equal to how much? You know, this one will be the antinode and this will be the node. The distance between node and antinode will become how much for me beta? Lambda by 4. The next one is 3 lambda by 4. The next one is 5 lambda by 4. Isn't it? Is that clear?
Yes, sir.
So whenever an open organ pipe of length 1.5 meter, this length is given from me from here to here. This length is given as 1.5 meter. Is being dipped vertically into the water, and whenever a open organ pipe is immersed in the water, that will be acting as a what beta? A closed organ pipe, because this water level will be acting as of your closed end. So for example, if I'm taking when it has been closed, the fundamental frequency, whichever it has been popping is, say for example, 1 antinode and 1 node. So length will become for me lambda by 4. Now I'm slowly raising this tube in the open upward direction. When you pull this one in the upward direction, what is happening to the number of loops formed in that one will beta? That will be increasing, isn't it? So it is slowly raised and a tuning fork of frequency 600 is set into vibration and is placed above the open organ pipe. So somewhere here we are keeping a tuning fork. Okay, find the maximum possible resonances heard. Ante how many resonances valla deentlo ragalugutayi. So first let us try to calculate the fundamental frequency for this sound. As it is a closed organ pipe right now, so it is n is equals to V by 4 times of your L1. So frequency is given how much for me? Say for example 600. Calculation is equal. I'll make this one as 660 bit otherwise. So there is a frequency there. This one you make it as of your 660. So frequency is equals to your 660 is equals to V divided by your 4 into your L1. V is given how much beta? 330. In the 330 kg calculation. So 4 into your L1. So it is a 331s, 332s. So it is 4 times of your L1 is equals to your 2. Sorry, 8. So 4 L1 is equals to this much. So it is 4 L1 into 2 is equals to how much for me? 1. And L1 enta avutundana? L1 will become for me how much? 1 by 8 meter. Can I write like this? L1 is equals to your 1 by 8 meters. So the length when it is immersed in the water, the minimum length, how much I'm getting right now? L by 8. What will be the L2 beta? Can anyone tell me? What will be the L2? In the closed organ pipe, the frequencies are in the ratio of what beta? In the closed organ pipe.
1:3:5.
1:3:5. If length is 1, first one is 1 L by 8, the next one will become how much for meter? L2 will become for me 3 by 8 meters. Isn't it? So L3 will become how much for me beta? 5 by 8 meters. And L4 will become for me how much beta? 7 by 8 meters. L5 will become how much for me beta? 9 by 8 meters. And L6 will become for me how much? 11 by 8 meters. Okay. And L7 will become for me how much beta? 13 by 8 meters. Chudandi. Now what is the length of the tube he has given? 1.5. So is the value of your 3.8 is within the 1.8 or not? Isn't it? 3 by 8 value will be within the 1.8. 5 by 8 is also within the 1.5, whatever the length he has given for me, isn't it? Up to if I'm going right now, L5, L6 part 11 by 8. 13 by 8 will be equal to how much beta? 13 by 8 is more than 1.8. sorry, more than 1.5. Ona kada 13/8, but our length of the tube is given how much for me? Length of the tube is 1.5 only. So I can take only the frequencies which are possible in this length. So how many maximum per number of resonance can be possible in this one, beta? 6. Therefore I can say that maximum number of resonances, maximum number of resonances possible is equals to 6. So what should be the minimum length of the water should be filled, beta? Can tell me? Therefore, minimum length water should be filled is, water should be filled is how much, beta? 1 minus 11/8. Ante kada 1.5 అంటే అంటే 3/2. 3/2 minus of 11/8. అంటే ఇది LCM ఎంత అవుతుంది? 8. So this will become for me how much? 1. అంటే 1/8. అంతేనా? So minimum length should be equal to how much, beta? 1/8. Is that clear?
Yes, sir.
అర్థమైందా నెంబర్ ఆఫ్ రెసొనెన్స్ స్కేల్స్ క్యాలిక్యులేట్ చేయడానికి? So you got an idea right now. Whenever an open organ pipe is immersed in the water, it will be getting itself converted into your closed organ pipe. So make sure that one. So whenever an open organ pipe, I'll write with this pen right now here. Whenever an open organ pipe is immersed in water, it will act as closed organ pipe. It will act as of your closed organ pipe. Is that clear? So whenever an open organ pipe is being immersed in the water, it will act as of what, beta? Closed organ pipe. Clear for everyone? Sure. ఈ క్వశ్చన్ ఇప్పుడు మీరే చేయాలన్నా. Try to do it at everyone. I'll give you 2 minutes of your time.
Sir,
Basic question.
Side, back side one, sir.
చెప్పనా?
Down, sir.
Clear?
Sir, we can directly take L1 no, sir, for minimum length.
Yeah, you can tell. అంటే అర్థం కావడం కోసం రాశాను. Once you get an idea for next type of questions, you can directly write the answers like that. The minimum length మనకి 8 వచ్చిన అర్థం. That means what? L1 I can directly take it as answer from the next type. Okay na?
Yes, sir.
Sure. Clear for everyone? Sure. Next one. ఈ క్వశ్చన్ ట్రై చేయండి అందరూ. Fundamental frequencies of closed and open pipes are FC and F0 respectively. Okay na? They are joined together to form a single pipe. Find its fundamental frequency. Understand the question? See the question right now for me. Fundamental frequency of closed and open organ pipes are given as of your FC and as well as of your F0. This is the fundamental frequency of closed organ pipe. This is the fundamental frequency of your closed organ, sorry, closed organ pipe is FC, open organ pipe is nothing but of your O. They are being joined to form a single tube. Find the fundamental frequency. Can anyone tell me, beta? Can anyone tell me, see? Lengths will be different, obviously. Say, for example, if it is a open organ pipe, then length L1 undankunda. And this one is, say, for example, closed organ pipe. Then length say, for example, N2. You know that frequency in the open organ pipe is, I can write here, this frequency is N1 is equals to V by 2 times of your L1. And frequency for this one is N2 is equals to V by 4 times of your L2. Isn't it? Now you know that how to write the value of from the fundamental frequency. From this one, I can write L1 is equals to, sorry. So this will become for me L1 is equals to V by 2 times of your N1 is nothing but of your open organ pipe, isn't it? So for the open organ pipe, we are writing it by your what? F naught. Then the same way L2 will be equal to your how much for me? V by 4 times of your, this will become for me fundamental frequency, that is nothing but close, that is nothing but of your FC. So we got L1 plus L2. You have been combining to form a bigger length right now like this. Anagada. So rendu combined this will become for me L1 plus L2 kada. Isn't it? So combined frequency is becoming right now for me what beta? A closed organ pipe. So closed organ pipe length is nothing but of your L. That means I can write here V by 4 times of your effective fundamental frequency will be equal to your, it will become for me V by your 2 times of your F naught plus this will become for me V by 4 times of FC. Ante kada, L must be equal to your L1 plus of your L2. So in this one, this V, and this V will get cancelled. So this will become for me 1 by your 4F is equals to your 1 by 2 times of your F naught plus 1 by 4 times of your FC. Take the LCM and calculate the frequency of your F. F will be coming out for me how much better. So LCM for this one, if this will become for me F naught into FC divided by your F naught plus 2 times of your FC. So this will be the frequency of the combined one. Then frequency of yes, better. Okay.
Okay.
Sure. So types of waves la, I told you what are the different types of your waves part. So మనం ఇప్పటివరకు ఎన్ని అయిపోగొట్టాము. Types of waves లో formation of stationary waves ఒకటి అయిపోయింది ఇప్పుడు మనం. So by this we have completed the first one. Now let us try to go for the interference of your waves. What do you mean by interference of wave beta? Adding the waves that differ in the phase only. Adding the waves will differ in the phase only. That means when two or more waves of same frequency travel simultaneously in the same direction or nearly in the same direction in a medium, they superimpose to give a new disturbance, which we call as a what? Interference. What is interference beta? Adding the waves that differ in the phase only. Adding the waves that differ in the phase only. Is that clear for everyone? Chalo, let us try to go in detail about your next topic. Yeah. So next topic is concept of interference. This topic is even common for one more chapter called as wave optics beta. There again, I will not tell you the derivations of all this. Whatever the derivations are there, even in the optics, wave optics, that derivations also I'm doing here itself in the sound waves only. So this knowledge here, whatever you are doing, is also applicable for the coming chapter called as of your wave optics. So let us first try to define what do you mean by your interference part of relations. So what do you mean by interference? I told you that when the waves which are differing only the phase, they will be undergoing the interference. That means if I'm writing the definition right now here, when two or more waves, when two or your more waves of same frequency, of your same frequency travel simultaneously simultaneously in same direction, in same direction, in same direction of nearly along the same direction on a medium, in a medium. So they superpose, on each other, they superpose on each other and give a new disturbance, called interference of waves, Okay, so that is about your interference of your waves. When two or more waves, what? When two or your more waves of what beta? Same frequency. They should be of what beta? Same frequency, If they have been traveling simultaneously in your same direction, nearly along your same direction as in your medium, the superimpose each other to give a new disturbance. That new disturbance is called as of what? Interference of your waves. Is it clear? Is this definition clear?
Yes, sir.
Isn't it? I hope everyone knows Balasubramaniam, isn't it? He was a legend type of your singer. See, for example, if you might have been anytime hearing the music, or might be a song which has been sung by your 2-3 persons, isn't it? Or if you might have been seen anytime the concert of your A.R. Rahman, where you will be having your n number of singers in the background, and he will be singing or giving a music participation, or else anyone who is singing participation, and there will be even some singers or some what do you call that, vocalist, who will be singing along with them in the backward direction. Now see, if the frequency of the person who is singing is matching with the frequency of even the persons who are singing in the background, then only the music which you will be hearing will be called as a what? A soothing one, and it will give you a sight of a calmness for your brain, so that you will get relaxed. Like say if two singers are singing, and one is singing in a very bad voice, another is singing is a very good, and they both of them are standing side by side and singing, the result whatever is reaching to your ear, will it be a good or will it be a bad?
Bad.
Obviously bad. Endukante when two persons of one very good singer and one very bad singer have been singing side by side, you can very easily identify that this fellow is worstly singing and this guy is really doing really very great job in his singing job, basically, isn't it? That means if the frequency whatever is being produced by the one person and the frequency produced by other person, both of them are syncing. Now even there are certain types of songs you might have been seen that where the female voice and the male voice will be coinciding, and the songs will comes out in a very beautiful ways, because there will be a coherence between them. What do you mean by coherence? Same. What do you mean by coherence? They will be having the same amplitude, same tune, same frequency. They have been superimposing. Our rendu add up ayi mana chevloki vastundi. So they'll come to our ears, so that we can able to identify that song and say that, so what a beautiful song is it, or what is an awesome type of a song is it. So will he give you an impression for that one or not? Like say if the voice of the male and the voice of the female are not coinciding, and the resultant is coming out to be very bad, you never listen such type of your songs. Anna kada. So even if the two persons are singing, or more than two persons are singing, if you might have been seen anytime the concerts right now, or the TV also, if you might have been seen so many shows like part of the Tiaga, there are certain type of shows where the 2-3 singers or 4 singers can also sing simultaneously to compare their what do you call that one capacity of your singing. So if 3 persons are singing, or 2 persons are singing, or 4 persons are singing, if the frequency of all of them are matching, then only thus output whichever has been coming out, that appears to be a very 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 happy type of your note, or maybe a new disturbance, a new wave which is always been giving a good sound of your hearing to your ear particulations, isn't it? So what I mean to see here in this one is, whenever more than 2 waves are being produced and both of them are traveling with the same frequency in the same direction, along the same direction of a medium, they will superimpose to give a new wave that is called as of your interference of your wave. Is it clear for everyone? Is it clear for everyone?
Yes, sir.
Yes, sir.
ఇంకా అర్థం కాలేదు ఎవరికన్నా? వాయిస్ అసలు ఎవరు మాట్లాడడం లేదేంటి? అన్మ్యూట్ ఆప్షన్ లేదా మీకు? ఉన్నారా బాయ్స్ అసలు? అరే 36 మెంబర్స్ ఉన్నారు. అభినవ్, చరణ్, అభినవ్, జయంత్, రమాకాంత్, అభినవ్,
సార్
అన్మ్యూట్ ఆప్షన్ లేదా మీకు? అర్థమవుతుందా చెప్తుంది?
అర్థమవుతుంది సార్.
మళ్ళీ ఏం మాట్లాడారంటారు మధ్యలో? ఎస్ సార్, నో సార్ అని చెప్పాలి కదా. ఓకే, చలో బేటా. So I hope everyone has been clear about this one. Interference of the wave. When two or more waves of same frequency are simultaneously in the same direction of nearly the same direction as that of your medium, they superimpose each other to give a new disturbance, which we call as of your interference. Is that clear for everyone? The definition is clear kada andarki?
Yes, sir.
So interference waves ni manam emantam same frequency avi kuda unnai kabatti they are also called as of your what type of waves? I called you coherent waves. Coherent waves. Coherent waves means same frequency. There is no phase lag between them, beta, or there is no variation. Phase difference between their sound waves is always remaining constant. So what do you mean by coherent waves? There are no vibrations in this one, beta. No vibrations in phase difference. In phase difference, and it is constant. And it is constant. That means phi is coming out for me or constant, isn't it? Or it is phase. There is no initial phase, I can say, isn't it? Same frequency and with no initial phase between them, that is called as of your interference. Is that clear for everyone? Is that clear for everyone?
Yes, sir.
Yes, sir.
Chalo, very good. We are having two different types of your interference between our syllabus. The first one is called as of your coherent interference or constructive interference. Constructive interference. Constructive interference. Constructive interference ante like when a male voice and a female voice are singing a song and the frequency of both of them are matching, the resultant output whatever you are getting is a very good sound or very good vibration. That is called as of your constructive interference. I hope everyone got it better. So I can say here right now, when two coherent waves. What do you mean by coherent waves? Phase difference between them is always constant, or they are having the same frequency and moving in the same direction. When two coherent waves in same phase, or I can say no phase difference, there is no phase difference or lag in between them, isn't it? They superpose, then such interference is called constructive interference. Constructive interference. దీనిపైన ఒక డామ్ షూర్ క్వశ్చన్ ఫర్ కాంపిటేటివ్ ఎగ్జామినేషన్, because this topic is common for the sound waves and wave optics and very important topic also. So make sure that this is the concept for the two chapters, that is coming chapter wave optics la kuda manaku constructive interference, destructive interference అని వస్తది. అక్కడ నేను మళ్ళా ఇదే గనక నేను చెప్తుంటే ఆ టాపిక్ మాత్రం I will be not teaching you at that time. Again you need to remember or come back to this chapter and revise this one. I'll be doing only applications of the constructive interference in the wave optics chapter. I hope everyone are clear with the definition of your constructive interference. When two coherent waves in the same phase or no phase difference or lag between them, no phase difference or lag between them, superpose, then such interference is called as of what? Constructive interference. Isn't clear? So let me draw the diagram and help you out so that it will get much clarity for you. ఇది మన దగ్గర ఒక వేవ్ ఉంది అనుకున్నాం. So here there is one wave going like this. There is one more wave going like this. And finally we are having one more wave like here. Okay. And this one is, say for example, wave 1. And this one is, say for example, wave 2. And this one is your resultant. Okay. Say for example, the first wave is like this. 1, 2, 3, 4, 5, something like this. And this is a point of what beta? Node. This is the node. This is the node. And this is also your node. So if I take the point of your nodes right now here like this. Okay. And here is one more wave like this. Let's say for example, దీని యొక్క amplitude ఇక్కడ నుంచి ఇక్కడ వరకు మనకు ఏ ఉంది అనుకుందాం. ఇంకో వేవ్ ఉంది ఇక్కడ. So this one is also going like this. ఇక్కడ వరకే వస్తుంది. This one is also దీని amplitude కూడా ఏనే ఉంది. Isn't? ఈ రెండు ఇప్పుడు యాడ్ అయిపోయాయి అనుకోండి. Isn't? This is the equation y1. And this is the equation of y2. The wave going in this direction. This wave y2 is going in this direction. So resultant ఏమవుతుందన్న? So what is the resultant wave what we are getting? This a గనక add అయిపోతే what I will be getting better? It should be equal to how much for me? They are in the same direction kada. Isn't it? So they'll get add up. So a plus a, that will become for me how much better? 2a. దీని amplitude ఇక్కడ నుంచి ఇక్కడ వరకు on y axis I am taking a. On your y axis దీని amplitude కూడా a. The resultant ఏమైపోతుందన్న? ఇట్లా పెరిగిపోతుంది అమాంతంగా. రెండు సూపర్ ఇంపోజ్ అవుతున్నాయి కాబట్టి ఇది ఇట్లా పెరిగిపోతుంది ఈ విధంగా. Then here also it will increase like this. And here it will increase like this. అర్థమైందా?
Yes, sir.
దీనికి నెగటివ్ కాబట్టి this one is minus a. అంటే దీని amplitude ఇక్కడ ఎంత అవుతుంది ఇది? This will become for me minus a. దీనికి కూడా ఇక్కడ కూడా amplitude ఉంటుంది కదా. This one is also your minus a. అంటే this one will be equal to your minus a. అవునా కదా? మరి ఇప్పుడు రెండు యాడప్ అయిపోతే మనకి ఇక్కడ ఏమొస్తుందన్న? దిస్ amplitude will be coming out for me how much beta? A plus a. That will become for me your 2a. And here also a plus of your a in the downward direction. So what I'll be getting here right now? This will become for me minus of your 2a. అర్థమైందా? So what is happening to the amplitude? Is it increasing or decreasing?
Increasing.
Isn't it? క్లాస్ లో ఒక్కడే ఉన్నాడు అనుకోండి, వాడు మాట్లాడితే క్లాస్ లో డిస్టర్బెన్స్ ఉంటుంది. ఇప్పుడు మొత్తం మీరు క్యాంపస్కి వచ్చారు, ఆఫ్లైన్ క్లాసెస్ స్టార్ట్ అయ్యింది. టీచర్ లేట్ అయ్యారు అనుకోండి క్లాస్ లో, మీరు అందరు కూర్చొని ఏం చేస్తారు? బుద్ధిమంతులు అందరూ శివరం ఓపెన్ చేసి చేసుకుంటూ కూర్చుంటారు కదా, అవునా? ఏం చేస్తారు? సార్ లేట్ అయినా క్లాస్ లో ఎవరు లేకపోయినా ఏం చేస్తాం మనం? చెప్పరే, బుక్స్ తీసి చదువుకుంటూ కూర్చుంటాం కదా, అంతేనా? సార్ మేము మాట్లాడాలి సార్, కూర్చొని చదువుతూనే ఉంటామంటారు. వినయ్, టీచర్ కొంచెం లేట్ అయితే ఏం చేస్తాం? క్లాసులో అల్లరి చేస్తామా లేదా? అల్లరి చేసేటప్పుడు ఆ రూమ్ యొక్క ఫ్రీక్వెన్సీ కానీ సౌండ్ కానీ ఏమైపోతుంది? పెరిగిపోతుంది. ఎందుకని? ఒక్కొక్క పర్సన్ ఒక్కొక్క ఆంప్లిట్యూడ్ ఉంటుంది. అందరూ మాట్లాడడం స్టార్ట్ చేస్తే క్లాస్ మొత్తం గోలగోల అవుతుందా లేదా? సో దాని ఆంప్లిట్యూడ్ ఏమైపోతుంది? పెరగడం తగ్గడం అవుతుంది, డిపెండింగ్ అపాన్ ద గివెన్ కండిషన్. మీ ప్రిన్సిపల్ మేడమో, వైస్ ప్రిన్సిపల్ మేడమో, లేకపోతే డీన్ సారో, లేకపోతే డైరెక్టర్ సారో, చైర్మన్ సారో ఆ క్లాస్ నుంచి ముందుకు వెనుక వస్తున్నారు చెప్పారనుకోండి, అప్పుడు ఏమైపోతుంది? క్లాస్ మొత్తం కామ్ అయిపోతుందా లేదా? అంటే ఎట్ టైమ్ ద ఇంటర్ఫియరెన్స్ విల్ బికమ్ హౌ మచ్ ఫర్ మీ? 0. అందరు ఒకటే ఫ్రీక్వెన్సీలో బుక్స్ ఓపెన్ చేసి చదవడం చేస్తారా చేయరా? The same thing is here about your constructive interference. So in the constructive interference, when more than 2-3 waves are being superimposed or getting added up, the resultant intensity will be addition of that one. Such type of interference are called as of your constructive interference. I hope everyone got an idea about your constructive interference.
Yes, sir.
Sure,
Yes.
very. The next one is destructive interference. Destructive interference. Okay. Now destructive interference అంటే దానికి opposite. That means when two coherent waves, superpose on a medium particle. On a medium particle in opposite phase. In opposite phase. అంటే phase difference దీనికి phase difference is equals to, say for example, pi. Then it is termed as destructive interference. This is it is terms of what, beta? Destructive interference. Okay. So what do you mean by destructive interference? When two coherent waves superimpose in a medium, when two coherent waves superimpose in a medium of a particles with opposite phase, with your opposite phase, or phase difference is equals to your pi, then it is called as of your destructive interference. Then it is called as of what? Destructive interference. Like say, inka easy ga cheppalanukunte, like say for example, your classroom is having, like say for example, 5 tube lights, isn't it? If you on one tube light, second tube light, third tube light, fourth tube light, and fifth tube light, all of them simultaneously, then what happened to the intensity of the room? What happened to the intensity of the room or brightness of the room? Very huge brightness వచ్చేస్తుందా లేదా classroom లో? If all the 5 tube lights are being on in your room simultaneously or one by one, then what is happening to the brightness of that classroom or your room, maybe whatever it happened? Intensity, brightness
Increases.
you'll feel little bit comfortable. Like say for example, if you're sitting in a room and we are having 3 tube lights, if I on one tube light and studying, you feel little bit okay. If second light has been on, you still feel little bit comfortable, your eyes will not get strained. If third one is also been on, what is happening? It will be more brightness, so it is still more comfortable for you to listen. Ana kada? Yeah. The same way, like say for example, if it is the evening study hours for you in the campus for the hostel students, like say it is 8 o'clock or 9 o'clock in the evening and you're studying in the classroom. If the in the 5 tube lights, if I switch off the 4 tube lights, will it be comfortable to sit and study in the classroom? No kada. Indukani intensity of the room is continuously decreasing, your eyes will get strained, isn't it? So when all the tube lights is on, the all of them are constructively interfering and they will become for me the maxima, isn't it? Just give me a minute time, better. I'll come back. When two coherent waves superimposed on a medium in an opposite phase with a phase difference of your pi, such type of interference is called as of what, beta? Destructive interference. I'm audible kada for everyone?
Yes, sir.
See, how do you understand with the help of diagram? You see, this is one wave like this here, and this is your another wave here right now like this, and here we are getting another wave like this. Okay, say for example, wave is being superimposed like this. I'm drawing here right now, so you'll get a clarity. Sure. So what is happening right now? From here, I'm taking the one wave beta, and this wave is going in this direction for me. I'll take with this pen. Yeah. This wave is undergoing the interference like this. This is your node, and here there is your node again, and here there is your node here again, and then here there is another node. Like little bit go like another. Then there is another wave which is been interfering with the phase difference of pi. And this will be equal to like this. And this wave interfere will go like this, and this will interfere like this, and from here this will be going like this, isn't it? Now see here, this is having an amplitude from here to here, say for example plus a, and this is having an amplitude right now from here, say for example of your how much for me minus a. And this will be having right now here plus a amplitude, so this will be equal to your plus a, isn't it? And this will be having an amplitude right now for this one, so this will be equal to your minus a. Go on like that one. Ardhamainda? So this is your node, this is your node, this is your anti-node, and this one is also your anti-node. This one is your plus A, and this one will be equal to minus A. This one is your plus A, this one will be minus A, and this one will be your minus A. Now, what is happening? You see that if you see this carefully, they are trying to interfere both of them. So one wave is like this, and here is another like this. So this one is another like this right now, and this one is interfering like this. So this is your x-axis. This is a wave 1. This is your wave 1 y1. This is your y2. This is the resultant. This resultant means this is y1 plus of your y2. So what is happening to the amplitude? Can you tell me at this position better? On your y-axis, this is y-axis. Here it is plus A minus A. What will be the amplitude here?
0.
0. Amplitude will become for me how much? 0 kada. So this is plus A minus, this is minus A. Ardhamainda?
Yes, sir.
Isn't it? So both of them are interfering in opposite phase. The resultant amplitude will become how much for me? 0. Like say in a tube light, in your room, there is only one single tube light. When you on it, the room will get brightness. When you off it, the room will get again darkness. Isn't it? Like on and off switch type of a condition. Is it clear? Is it clear?
Yes,
Sir.
Now let us try to understand this one with the help of your analytical method better. Time అయిపోయింది అప్పుడే ఈరోజు 8 అవుతుంది దేవుడా. Okay, we'll try to do this derivation in the tomorrow session of a class beta. Analytical treatment or analytical way of your deriving it with mathematical way. We'll try to do it in the tomorrow session of a class. So I hope you're clear about this all things basically. Okay,
Yes,
na?
sir.
So what you do is
Yes.
today in the study hours, whatever the assignment which have been sent to you. Where is that assignment? ఇది పంపించాను కదా ఈ అసైన్మెంట్స్ లో గ్రాఫికల్ సొల్యూషన్స్ గ్రాఫికల్ బదులు ఈ అసైన్మెంట్ 2 ఉంది చూడండి ఈ అసైన్మెంట్ 2 లో ఈ రోజు వాట్ యు డు ఇస్ క్రిటికల్ థింకింగ్ ఉంది అదంతా ఆర్గాన్ పైప్స్ వైబ్రేషన్స్ ఆఫ్ ఎయిర్ కాలమ్స్ ఉన్నాయి బీట్స్ కాన్సెప్ట్ వస్తే విడిచిపెట్టండి అన్న ఆర్గాన్ పైప్స్ అండ్ వైబ్రేషన్స్ ఆఫ్ ఎయిర్ కాలమ్స్ ఈ రోజు అయిపోగొట్టండి దిస్ క్వశ్చన్ నెంబర్ 1 నుంచి క్వశ్చన్ నెంబర్ 53 వరకు దీంట్లో అక్కడక్కడ కొన్ని బీట్స్ కాన్సెప్ట్స్ వస్తాయి బీట్స్ కాన్సెప్ట్స్ కనుక ఏమైనా వస్తే ఫ్లైన్ గా విడిచిపెట్టండి మనం బీట్స్ కాన్సెప్ట్ చేసిన తర్వాత చేద్దాం మీకు ఈ 1 to 53 లో ఎన్ని క్వశ్చన్స్ అయితే అన్ని క్వశ్చన్స్ కంప్లీట్ చేయండి ఏమంటున్నాను చేస్తారా
Yes, sir.
రేపటి వరకు కంపల్సరీ అయిపోగొట్టాలి ఇది ప్రతి ఒక్కరు నాకు నోట్బుక్ లో చూపెట్టాలి వీడియోస్ ఆన్ చేసి చెప్తున్నాను ఇప్పుడే వైబ్రేషన్స్ ఆఫ్ సారీ వాట్ ఈస్ దట్ హెడ్డింగ్ ఐ హావ్ గివెన్ యూ రైట్ నౌ ఓపెన్ పైప్ వైబ్రేషన్స్ ఆఫ్ ఎయిర్ కాలమ్ అని హెడ్డింగ్ ఉంది దాంట్లో okay so that is in the page number enta 855 page number 855 organ pipes question number 1 nunchi no need of writing the question just keep that question and try to do the working on your own so 53 questions unnai oka 1 hour 2 hours కూర్చుంటే అన్ని అయిపోతాయి ఏమంటున్నాను ఎన్నైతే అన్ని చేయండి రానివి విడిచిపెట్టండి or else you take the help of your solution అప్పటికి రాకపోతే you try to talk me I'll try to help you out okay na చేస్తారా అందరూ
Yes, sir.